Today I played around with this near field communication device, and what we're gonna do in this video, first we take a look to the responders, then we connect it to an Arduino and read the data from the responders. Then we write some code to open our door, so we use the transponder as our key, and on the end we're gonna write some data from the device to the tag. The device arrived like this, and you have to solder the pins on there yourself. In this schedule you see an overview how it works. This is the device which powers this coil, and that creates a magnetic induction. And if you hold the tag close to the device, then the induction will power the tag, and inside the tag is also a coil, and the coil will pick up the power and feed the chip, and then they can communicate on this frequency. I carefully opened a tag, and you can see the coil in there and the chip, and inside this credit card shape is also a chip. And if you hold it close to the lamp, it shines through, and you can see the chip and the coil. And in this drawing you can see how I connect the device to the Arduino. You can feed it with 3.3 volts, and this is the SAD pin, and on all devices sometimes it's the SS pin. So if you have a SS pin, you can power it on pin number 10. Inside the Arduino compiler I downloaded a library called MFRC. If you don't know how to import a library, watch the link over here. Then I went to File, Examples, RC522. And then I select dump info. Then you come in this file, and if you compile it and you open up the serial monitor and you hold a tag close to the reader. So I hold a tag close to the reader, and the device reads all the information out of the tag and dumps it inside the serial monitor. Every tag has its own unique ID number. That's this one over here, and you can see that the tag can store 1 kilobyte on data, and that 1 kilobyte of data is divided inside 16 sectors from 0 till 15, and every sector is divided inside 4 blocks, and every block can store 2 bytes of data. The device needs around 6 seconds to read everything. If you just hold the tag for, let's say, 2 seconds before the reader, then you get something like this, then it's failing. But if you do it carefully, like 6 seconds, you get a whole data dump. And you can see that on the first row from section 0, so 00, the tag stores its own identity, and now we know the identity, we can write it inside the code. I opened a new example called File, Example, and this time I opened Read Node, and I modified the code a little bit, and I will put this link to this code in the description of the video. And I modified it everywhere where you'll see a long row of exclamation marks. So if you see exclamation marks, you know that I changed something over there. And what I did was I stored the tag ID inside this byte, and I also made a boolean named known. And inside this for loop, the byte of the tag will be compared with the byte from the reader, and if all the characters are true, it will turn the boolean known to true, and if known is true, then it opens the door. and if it's not true it says no access. And I compiled the code and I hold a tag before the reader, and you'll see that it was comparing and it was true, and then it opens the door. And if I hold another tag before it, then it says that it is false and there is no access. And if I hold the other tag before it, then it's true again. So that's how you can use the ID of the tag to do something inside your code. Now let's take a look how to write some information to the tag. And to write some data to the chip, I found a nice sketch on this website over here. I will put a link in the description. And what this code is basically doing, we write 16 bits to the second block. So inside sector 0, the second block, we write one line of code. And that's this line. And the word we write is subscribe, because I love it when people subscribe to my YouTube channel. If you want to clear the chip, you can use this line of code. Just uncomment it and comment this line. You will write only zeros back inside the memory. Press upload and open the serial monitor and place the chip before it, and you'll see it says subscribe. And I uploaded the dump info sketch back to my Arduino and tagged the chip. And as you can see over here on line 2, we override the zeros with all kind of figures. And if I place a blank chip for the reader, then you can see that on line number 2 there are only zeros. Make sure you never override the first line of sector 0, because on that line is the chip identity. This is the end of the video. Please subscribe to my YouTube channel so you do not miss the upcoming videos. I will put a link to the code in the description, and thanks for watching.